Alright, so this device here is a spectrophotometer, and it is hooked up to a computer. And essentially what this does is inside of this little slot here there are a bunch of different colored lights, and it can emit all different wavelengths of light. I believe it goes somewhere from about 300 nanometers to 900 nanometers. This one can actually read and emit between the infrared and the UV range along with visible. So it can even emit and detect waves that we can't necessarily see with our own eyes. And there are detectors inside of here as well. And what you do is you take this standardized, this is called a cuvette, so it's a standardized container, and there are ridges you hold with your fingers, the side with the ridges, and then it's actually reading the light through the more transparent side. So this is how it is designed to read. And that's just distilled water. So first I'm going to calibrate my spectrophotometer just with the distilled water. And then what I'm going to do, and I'll show you that next, is take a cuvette with our copper solution, and I need to figure out which wavelength of light is absorbed the most in that cuvette. And so that's what I'm going to do first, is tell you what it's called lambda max. Lambda is the Greek symbol for wavelength. We're going to figure out what color of light this absorbs best. And what I can tell you right now is if we can see with our own eyes blue light traveling through this solution, that means that this does not absorb blue waves, so it must be absorbing light in some other wavelength and frequency, and that's what we're going to do, is figure out which wavelength does that absorb the best. And so that's the first part of what we're going to do here once I calibrate. Alright, so calibration's finished. That takes a little while, but I'm going to remove my blank with the distilled water and put in my copper solution. Okay, and then what we're going to do is start collecting data and figure out which wavelength is absorbed the best. And so that's what this is doing, is it's showing you from 380, which is, this is in nanometers, that'd be in the violet end of the spectrum, all the way up past the red. So here's red. Red is what, somewhere around 750, I believe. And what we need to figure out is what is the maximum absorbance. So on the y-axis I have absorbency, okay? And that's actually a logarithmic scale that's related to how much of the waves are being absorbed. And then this on the x-axis is my wavelength in nanometers. And what I'm looking for is lambda max, which is going to be this point right up here, okay? And so I need to figure out what this point is. And it is right up around 800 nanometers is my lambda max. So this says 804. A previous trial I ran gave me 810, but that's lambda max. And so what that's telling us is that this blue solution actually absorbs best in an infrared wavelength. And so what that's going to do, we're going to use a different type of spectrophotometer to actually run our trials. And all that's going to do is tell me which wavelength to use. This is, again, just another spectrophotometer. There's lights down there that it can send different wavelengths through. And what that tells me is we actually want to run this spectrophotometer in the 635 nanometer wavelength, because that's closest to 804, which is the lambda max. And even if you look on this scale, I would not want to run at 430 because this solution absorbs very little. You know, this would be somewhere around 430. As I told you, you can see it's a blue solution. Blue light travels through it. There's very little light being absorbed in the blue end of the visible spectrum. And so I wouldn't want to run my colorimeter with 430 or 470. It's just not going to absorb much light in that end of the spectrum. So I'm going to get just better results. I'm going to get a more clear. Okay, so you can see that I've got my colorimeter, which is just a spectrophotometer. That this one works at 4 different wavelengths. I have it set to 635 nanometers because my copper solution will absorb that wavelength the best, and I'll get the clearest picture and the least noise. I need to calibrate this, and that's easy with this device. I just have to hit the calibrate button and let it think for a little bit. Okay, and then you can see it's got absorbance set to 0, so it's calibrated so that that's just a distilled water solution and it shouldn't be absorbing any light. All light is being transmitted through it. Okay, so I'm going to remove that. And now I know the concentration. Jameson made up these different dilutions of our known copper nitrate solution. So we know that this is 0.400 molar, this is 0.200 molar, 0.100 molar, 0.0500 molar, and 0.0250 molar. And we know that because we made this solution. Jameson actually made that solution, and she made it 0.400 molar concentration. And then we performed a serial dilution where we cut the concentration in half each time sequentially. And so now what we're going to do is we're going to make a linear plot graphing concentration, which we know in all of these, versus the absorbance values. Okay, and so I'll start. This is my absorbance. Easy to do, just pop it in there. And the absorbance of my 0.400 molar solution is 0.300 or 0.299. That last digit's an estimate, so record that data. Okay. Next up, the 0.200 molar solution, and to your eye, it looks more transparent, right? There's more light passing through that solution. And so this colorimeter, spectrophotometer, is really not doing much different than what your eyes can do, but it's giving us different values. I don't think your eyes can give us this quantitative data, it's more qualitative. The absorbance is 0.252 for the 0.200 molar solution. Going in order here, 0.100 molar solution. Let it think for a second. Okay, the absorbance of that is 0.147. It's going down, which it should be, that makes sense. Less light in the 635 nanometer wavelength is being absorbed. Okay, this is 0.0500 molar, and our absorbance is 0.043. And finally, looks pretty transparent, not a lot of absorbance there. My 0.0250 molar solution has an absorbance of 0.035. Okay, so now you're going to take those data points and you are going to plot them, and we should get, hopefully, a straight line. And we know the concentration of these solutions, and now we can plot the absorbance. And then ultimately we're going to take our unknown and see where it fits kind of along that plot. Alright, so now all that we need to do is take our mystery unknown sample, and I want to figure out what is the concentration of this solution that we made. And ultimately we can tie this back, once we know the molarity of the copper ions in the solution, we'll actually be able to figure out how much copper was in the brass piece that we started with. So I filled up my cuvette with my unknown mystery sample. We take that over to the colorimeter and have it read an absorbency for the unknown sample. And now my absorbency is 0.277, and now you can take that data point and go figure out what the concentration of that solution is based on the graph that you made with our known values from the serial dilution that we did. So that was a different copper solution, but they're all copper nitrate, and so now all you have to do is put that data point into the graph you made, and you should be able to figure out what the concentration of our unknown solution is.